the ranges of the trig functions. And what that means is we want to know what are the possibilities for an answer to a trig problem. You know, what do they look like? We know they're numerical, but we want to know, like, what are the possibilities? Can it be any number? Or, you know, is there set numbers that it can be? And so what it is sine and cosine, no matter what the angle is, the sine and cosine value will always be between -1 and +1. You can never have a sine value or a cosine value that is greater than 1 or less than -1. Now, usually I tell my students, I don't do well with set notation here in the middle. I only really have the interval notation memorized. So for me, this is enough, and it's more about applying it anyway. So if you just want to memorize these, -1 to 1 is sine and cosine. Now, tangent and cotangent, they're the nice ones. They can be anything at all. You could get 1,000, you could get 0.001, you could get -7. Tangent and cotangent can be anything at all. So they go from -infinity to infinity. And finally, the range of answers you can get for secant and cosecant can be anything except what's in between -1 and 1. So secant and cosecant can be anything that sine and cosine can't. The only places they share are -1 and 1. So secant and cosecant can be -1 and +1, but they can't be anything between them. Sine can be -1 and +1, as well as cosine, and anything between it, but nothing bigger than or smaller than it. Now I want to point out that these are not paired with their reciprocals. They are paired with what we call their cofunction. Sine, cosine, they go together. Tangent, cotangent go together. So that's the only one that's paired with its reciprocal, is tangent. Secant and cosecant. So this is different because they're paired differently. You do need to memorize those. It's very important when you get an answer that you know whether it's possible or not. Okay, so for this example, I'm just going to list a few trig functions and values, and you tell me whether that's possible or impossible. Sine of an angle equals 2.5. Possible or impossible? Impossible. It's impossible because sine and cosine both have to be between -1 and 1. So 2.5 is too big. Tangent equals 110.47.
Yes.
That's possible. Tangent and cotangent can be anything, so they're always possible. Can secant of an angle equal 0.6? No, why?
It's got to be anything but between 1 and 8.
Right. Secant and cosecant cannot be in between 1 and -1. So that would be impossible. Any questions about that? The reason we bring it up is eventually we will graph trig functions and it will help to know that. However, another thing is when you work a problem, if you get that the sine is 2.5, you have done something wrong. So we're hoping to give you some tools that you can kind of check yourself with. Now, as I said, this section is just a bunch of random stuff shoved together, just stuff that we need to get out of the way and we need to get under our belt. So here's a completely different thing. We're going to just suppose now that an angle theta is in quadrant 2 and that we know that the sine of that angle is +2/3. Given that those two pieces of information, quadrant 2 and that the sine is +2/3, we would like to find the values of the remaining 5 trig functions.
Because that's not complicated.
Not at all. So given that an angle is in quadrant 2 and that the sine of that angle is +2/3, we want to find the remaining 5. Well, what's one that we know right off the bat? We know if sine is 2/3, then we know that cosecant is 3/2. So I guess we'll just start there. Cosecant has to be 3/2. And that's pretty much the only one that we know. We have to figure out a method that will allow us to find the other 4. Here's kind of what I've always taught students. Take it and draw it in the proper quadrant. So this is in quadrant 2. So there's a triangle out there somewhere, right?
Mm-hmm.
Now because the sine is 2/3, what's the definition of sine?
Or y over r.
Y over r. So if this is equal to y over r, then that means the y value is
2.
positive 2 and the r value is positive 3.
Wouldn't that make the value there one time?
What would the x value have to be, positive or negative? Because it's in quadrant 2, so we have to be careful. Now the r value is always positive, but x and y can be positive or negative depending on your quadrant. So what we're doing is we're kind of working in reverse. Instead of me giving you x and y, I'm giving you a trig function. You can use it to find 2 of the 3 things, x, y, r. Now just go through, use the Pythagorean theorem, and find that missing x value. So if I want to know this x value, right here, I know that x squared plus y squared must equal r squared. So we know that x squared plus 4 has to equal 9. So x squared is 5, which means x is plus or minus square root of 5.
It's got to be negative.
And because it's in quadrant 2, the x value of any ordered pair there has to be negative. So we're going to say that x is negative square root of 5. So here's what we know. X is negative square root of 5, y is positive 2, and r is positive 3. And once I know those 3 things, I can find any trig function I want just by using the definitions. So let's go ahead and find cosine. Cosine of that angle has to equal the x value divided by the r value. So in this case, that is negative square root of 5 divided by 3. How about tangent? What's the definition of tangent?
Y over x.
Tangent is always equal to y divided by x. So in this case, that's going to be the tricky one. 2 divided by the negative square root of 5. I have to rationalize that, and we never leave a negative in the denominator, so we're just going to float it up to the top. And when I multiply top and bottom by the square root of 5, I get negative 2 square root of 5 all over 5. All right. What do you want to find next? Cotangent?
Sure.
Okay, so cotangent. Cotangent of an angle is the reciprocal of tangent, so that would be x over y, which in this case is negative square root of 5 over 2. And I think we're missing one more, which is
Secant.
secant. Okay. Who's secant the reciprocal of?
Cosine.
Cosine? Let's see.
3 over square root.
So that's 3 over negative square root of 5,
So it's negative.
or r over x, if you want to do it from the definition. R over x, which is 3 over negative square root of 5, which rationalizes to negative 3 square roots of 5 over 5. I think these are probably some of my favorite problems. I like that if you know just a couple of things, like you can find so much from it, and you can figure out where it is on a graph, and it's not even a graphing problem. Like, that's really neat to me. So, and I guess I just like the thought process involved here. Any questions about that? And guys, you could do that for any combination, but I have to give you enough information to locate the quadrant. Otherwise, you don't know who's positive and who's negative. Also, at the end, you can check yourself by making sure, depending on the quadrant, that the proper 2 are positive. 4 of them have to be negative. And if I'm in quadrant 2, sine and cosecant are the only positive ones. And we can see that that's true. And the other 4, this one, this one, this one, and this one are all negative. So you can kind of double check yourself.